Hello class. Today let's go over a few problems from section 3.2, and I want you guys to read the information here. Now let's go over exercise number 1. Now here always the term with the highest power determines the end behavior of the function. So x to the power 4. Basically we are checking if x is very close to negative infinity, x to the power 4 will be positive infinity, isn't it? If x is infinity, then x to the power 4 will again be positive infinity. So in both direction it is going up. Now number B. What is the leading term on the B? There is a 2x cube. You multiply with x, that gives 2x to the power 4, and you multiply with another x, so the leading term will be, if you expand, it will be negative 2x to the power 5. That is the leading term. Now let's check. If x goes very close to negative infinity, what happens? Infinity multiply 5 times negative, and multiply by negative 2, it will be positive. So it will be positive. Negative 2x to the power 5 will be positive. Now if x goes to infinity, infinity to the power 5, positive, times negative 2, negative. So negative 2x to the power 5 will be negative infinity. So what is it telling us? On the left hand side it is going up because positive infinity. On the right hand side it is negative infinity. That's why it is going down. That's how we find the end behavior of the function. Number 2. What is the leading term here? Negative 0.27x to the power 3. Now here, if x is here, number of students is increasing. So if x is increasing, if x is very big number, infinity, then positive times negative is negative. So negative 0.27x to the power 3 will be negative infinity, and which does not make sense, because what is it telling us? They will be borrowing so many computers, which does not make sense. That's why this model is not the proper model. Number 3, we are finding zeros, and as we learned in the previous section, finding zeros means we are solving for x. 0 equals x cubed plus 2x squared minus 4x minus 8, or in the another language we can call it x-intercepts also. There are 4 terms. There is nothing we can take out, so let's make the group of 2. Hopefully it will help. If we factor x squared out, we are left with x plus 2. If we take negative 4 out from the another group, we are left with x plus 2. Now here we can take x plus 2 out, x plus 2, remaining is x squared minus 4. Let's factorize that expression one more time. X plus 2, do you guys recall? X squared minus 4 is 2 squared, so it is the difference of the square. So it is x plus 2 and x minus 2. Then product of all these 3 things are 0. That gives x equals to negative 2. Another expression also gives x equals to negative 2. Another expression gives x equals to 2. That's how we find zeros of the function. Excuse me. It is x-intercepts also. Number B. 0 equals x to the power 4 minus 9x squared. Is there anything we can factor out? X squared we can factor out. We are left with x squared minus 9. That is x plus 3, x minus 3 equals 0. We got x squared equals 0, x plus 3 equals 0, x minus 3 equals 0. This gives x equals 0, this gives x equals negative 3, and this gives x equals to 3. So very basic process. In the next section we will be having little bit complicated expression, and we will have different idea. And here, this is the information I want you guys to read so that it will help. Now, exercise number 4. We have to find out the multiplicity of each zeros and talk about whether it crosses x-axis or touches x-axis and turns around. So to find the zeros, we set up output equals 0, negative 4, x plus half square, x minus 5 cube. So dividing both sides by negative 4, we will get x plus half square, x minus 5 cube. The first expression gives x equals negative half twice, and the second expression gives x 5 3 times. So this zero has multiplicity 3, this 0 has multiplicity 2 because it is repeating that time. Now what we learn, if it is odd time, then it crosses x-axis. If it is even number of time, it turns and turns around. That is the properties of multiplicity. Here is the process how to graph polynomial function. I want you guys to go over this. Now let's do exercise number 5, which summarize everything we learned in this section. First, we find the end behavior. What is the leading term? Leading term is x cube. If x cube is a leading term, if x goes to negative infinity multiplied 3 times, negative times negative times negative. So negative, if it is negative, so it is going down. On the left, it is going down. If x is positive infinity, positive, if you multiply 3 times, positive, so it is going up. So on the right up, left down. So we find the end behavior. The second thing we find is x-intercepts. To find the x-intercepts, 0 equals x cubed minus 3 x squared. 0, x squared we can factor out, x minus 3. It is giving x 0 2 times, and then it gives x equals to 3 1 time. What does that mean? If 2 times repeating even number of times, touches the graph, touches at 0 and turns back. That is the meaning. At 3, it says crosses x-axis at 3. That is the meaning. So we find x-intercepts. Now let's find y-intercept. Just plug 0 in the function f of 0. This equals to 0 cube minus 3 times 0 square. That gives 0. So the y-intercept is also for x0, y0. Now let's make the rough sketch. On the left hand side, it is going down. So that means I'm going to make the graph like that, going down. and it goes all the way to 0. Here is 0, and it turns back. It does not cross like that, but at 3 it crosses, and on the right hand side it's going up. So here the graph is not that nice, but you guys understood. That's how we graph the polynomial.